Welcome back to Air Quality Matters and One Take. One Take, my take on a paper or report on air quality, ventilation and the built environment. One Take it's in one take and tries to summarise for you a scientific perspective on something in usually 10 minutes or less, because who has the time to read all these amazing documents, right? This week, something quite different from usual. We're looking at a space where hundreds of people are packed shoulder to shoulder in sealed metal tubes for hundreds of hours at a time. High-speed trains. The paper is titled Study on Air Quality Improvements in Train Compartments by Coordinating Exhaust of Multiple Air Outlets, published in Railway Engineering Science. Who knows what you do without Google Scholar, right? It's amazing what pops up. Anyway, if the pandemic taught us anything, it's that ventilation in confined, crowded, mass transit spaces is absolutely non-negotiable for public health. In a train carriage, engineers have a massive, complex challenge. If you think about it, you need to keep 90 to 100 passengers thermally comfortable, not freezing, not sweating, while simultaneously extracting the CO2, the VOCs, and potentially infectious respiratory aerosols they are exhaling, all while trying to minimise energy consumption and sending that tube down the tracks at 100 kilometres an hour. Most modern trains pump fresh conditioned air in from vents in the ceiling, but where does that stale air go? Usually it's exhausted through vents down near the floor. This study used CFD modelling to look at what happens if we rethink that. What if we coordinate exhaust at both the top and the bottom of the carriage? The researchers modelled a fully loaded carriage right down to the heat emitted by the passengers. Because here is the physics of it. Human bodies create thermal plumes. We are basically 100-watt heaters, and warm air naturally rises off us, carrying our exhaled breath upwards. In the summer, when the air conditioning is trying to cool the cabin, if you exhaust the air entirely from the top of the carriage, like near the luggage racks, you are working with that natural thermal plume. The hot polluted air rises off the passengers and gets sucked right out of the top vents. The study found this significantly improves the cooling of efficacy and efficiency. You aren't forcing hot air down past passengers to reach the floor vents. It also clears out pollutants near the passengers' breathing zones much faster. But interestingly, it's not a magic bullet for all seasons. In the winter, the scenario flips. You're trying to heat the cabin. If you pull all the air out from the top vents, you are just sucking all that nice, buoyant, warm air straight out of the roof before it reaches the passengers, leaving their feet freezing. It creates massive temperature stratification and makes people incredibly uncomfortable. The study found that in winter, a 50-50 split using both the top and the bottom exhaust provides the best balance. The bottom exhaust pulls the warm air down to feet level, maintaining thermal comfort, while the top exhaust still helps capture the rising respiratory pollutants. So, what does this mean for our transport infrastructure? Why is this interesting? Well, it proves that static one-size-fits-all vent designs is dead. You cannot have a ventilation system that operates the exact same way in January as it does in July and expect optimal results for both comfort and, importantly, infection control. We need dynamic systems. If you want to truly manage the risk of airborne transmission in mass transit while simultaneously hitting our net zero energy efficiency targets, train manufacturers and frankly designers of any large, densely occupied space need to implement variable exhaust systems that adapt to the season, the thermal load, and the occupancy. It's a brilliant example, I think, of how nuanced, targeted, and responsive our ventilation strategies need to become to protect public health in the built environment, especially technical ones like trains. You can imagine the exact same thinking being applied to buses, to aeroplanes, and so on. Thanks a million for listening. As always, these podcasts are not possible without our partners, Safe Traces, Imbiot, Valmud, EI Electronics, the IO Institute, and Zender. Without them, they just simply wouldn't be possible. Thanks a million. Do check them out in the show notes, and I'll see you again next week.